Given these equations and their corresponding enthalpies, we can determine the change in enthalpy for the overall equation. The goal is to manipulate the three given equations in such a way that you end up with the overall equation through Hess's law, which sums up all the parts and cancels many of the intermediate products or reactants. There are two tools that are used to accomplish this. The flip. The equations can be flipped so the reactants become the products. If this is done, be sure to change the sign in the change in enthalpy. You can multiply through. Each coefficient in the equations can be multiplied by any fraction or whole number in order to match the overall equation. However, when this is done, the change in enthalpy given for that equation must also be multiplied by that same number. The goal is to cancel out the excess compounds or elements on each side of the equation, much like in algebra, in order to end up with the overall equation. The changes made to the equations given will correspond to the changes made on the enthalpies, which will give us the answer to the change in enthalpy for the overall equation. The first step is to ensure that the equations are balanced. As you can see here, these ones are. To begin, let's take each equation separately, starting with the first one. Look at the overall equation. Notice how nitrogen dioxide is a reactant in equation 1. To solve this part, we must flip equation 1, which causes a sign change from negative to positive in the change in enthalpy for question 1. Next, notice that there are 3 nitrogen dioxides in the overall equation, but only 2 in the first equation. Therefore, we must multiply through by 3 halves in order to solve this part. Remember that whatever you do to the equation must be done to the change in enthalpies. This gives you a version of the equation 1 that can be used. Next we go to equation 2. Notice that nitric acid is a product in both the overall equation and equation 2, so it does not need to be flipped. However, we need to go from 4 nitric acid in equation 2 to 2 nitric acid in the overall equation, so we multiply both the equation and the change in enthalpy by 1/2. Then we add equations 1 and 2 in order to cancel out the formulas we do not need in the overall equation. So in this case, we can subtract the oxygen from the product side and the oxygen from the reactant side, and then add the changes in enthalpies of the two equations, which in this case is positive 46. Now you can see that the nitrogen and the oxygen in reactants need to cancel out in our combined equation with equation 3. Therefore, we flip equation 3 so we have nitrogen and oxygen gas on each side. In order to cancel these, we must multiply the third equation by 2 in order to get equal numbers of both nitrogen gas and oxygen gas on both sides. Ensure to make the same changes to the changes in enthalpy. Then, we consolidate the equations and check to see that our new equation matches the overall equation. Once this is done, we can add up all our enthalpies from the given equations to get the answer, which in this case is negative 138 kilojoules. Thus, in this case, we can see that the reaction of 3 nitrogen dioxide molecules with water yields products and 138 kilojoules of heat.